Morning. I'm Ryan Malecky. I'm a solutions architect at AWS, and I'm going to be kicking things off. If I can figure out how to advance the slides. There we go. So yeah, I'm going to be kicking things off. I'm going to be covering some of the basics of running Tableau server on AWS. And then I'm going to be introducing Madeleine from Tableau. She's going to be talking about a really neat system she's built to analyze AWS billing data. And then we're going to hear from the team at the University of Maryland and get into some of the details on how they're using Tableau in production. So to start things off, considering why you're using BI on the cloud. We have lots of different data sources, lots of different places places data is coming from, lots of different use cases. A few trends we're seeing. First is moving data into S3 as an initial landing spot. From there, we frequently see customers using EMR, our Hadoop distribution, to ETL data, as well as to query it, leveraging a data warehouse. And then finally, using Tableau to gain insight and value from that data. Wrong button. So Tableau has a number of advantages. One of them is the awesome number of integrations it has, especially with AWS data sources. So we see customers using Redshift, our cloud-native data warehouse solution, that can handle data from gigabyte scale up to petabytes with fast, cost-effective performance. We see customers using EMR, our Hadoop distribution, and leveraging tools like Spark or Hive on top of that. We also see customers leveraging Amazon Athena. It's a fairly new service of ours that lets you run SQL queries against data in S3 without having to manage or provision servers. You just write a query, you get a result. So a few practical considerations when you're running Tableau on AWS. There are a number of ways to deploy it. The first is a self-service model where you provision an EC2 instance, you install the software onto it, you provision your license, and you're off and running. Another approach is leveraging the AWS Marketplace. The Marketplace is a storefront where you can purchase software from a wide range of our partners. The Marketplace will provide you with a pre-configured machine image, so you just have to launch the instance with that image, and you're set to start using the tool. In the case of Tableau, we have two options through the Marketplace. The first is a BYOL option, bring your own license. So here you leverage the pre-installed, pre-configured machine image, and you use an existing license you have with Tableau server. So you can get up and running quickly and leverage the investment you've already made. The second option is to leverage a license that you acquire through the Marketplace. Here you can start small and scale up as you go. So you have the pay-as-you-go pricing model similar to other AWS services. So when you think about Tableau, one of the aspects the University of Maryland found really useful is the ability to start small and grow as your demand grows. So you're only paying for the resources you're using as you're using them. We really encourage customers to provision a small EC2 instance when you're getting going. And as your business need grows, you can move to a larger and larger instance. There are two approaches to scaling Tableau on AWS. The first is a vertical approach. Here you're going to start with a smaller EC2 instance and provision larger instances if you need them. So you might start with a M5 large, and as your users are running more reports, as you have more users, you can move to an M5 extra large or an M5 2 extra large to meet that need. The second approach is scaling horizontally. Here you're leveraging Tableau Server's ability to run a primary and multiple worker nodes. And you can just add additional worker nodes as your demand grows. So a few architectural considerations when you're using Tableau on AWS. You're going to start with an EC2 instance that has the software installed. Then you're going to look at your data sources. So this could be Redshift, this could be a relational database you're using on RDS, or this could be a system like EMR. You're going to want to make sure that those resources are secure. Typically, customers are going to want to have access to databases really locked down. You don't want malicious activity or accidental exposure of data. So you can use security groups, which are stateful firewalls that AWS provides, to restrict access to your databases so that only Tableau server is able to access those data sources. Thinking about defense in depth, you can also leverage VPCs and subnets within those VPCs to control where traffic is coming from. So you have a public subnet that your Tableau server is sitting in, traffic from outside the VPC can reach in, and then you can put your databases in private subnets so that only traffic from within the VPC is able to reach those. A final consideration is where your users are coming from when they're accessing Tableau server. One approach is to leverage a public internet. So you can have traffic flowing over the public internet and hitting Tableau server. Another approach we see, especially with our larger customers, is to leverage private network connectivity. So you can either set up a direct connect or a VPN to extend your on-premise network into AWS and let customers connect over that. So I'm going to turn it over to Madeleine from Tableau now.
All right, thanks, Ryan. We all good? Everyone can hear me? I'm a little bit shorter, so I adjusted the mic. All right, hi, my name is Madeleine Corneli, and I work in product management at Tableau, supporting our technology partners. So building out joint solutions with partners like AWS to help people using Tableau and AWS do their job better. So I originally came from our field consulting team, so pre-sales, as it's sometimes known. And I had a question from a customer about a year ago. They came and they asked me, okay, is there a good way for me to monitor my AWS deployment using Tableau? And I said, well, I can't think of one that's really easy for you to set up right away. That was my sort of a fuzzy way of saying no. Now, if any of you are from the pre-sales org, you know that you don't really like saying no to customers. So I didn't really enjoy that experience, and I wanted to fix that problem. So as I transitioned onto this new team, I realized this was a great opportunity to explore how I could better support customers asking that type of question. Now, I wanted to make sure this was something relevant that lots of people were concerned about, so I did a little background research. And I found the RightScale report for 2018 that tells us that in 2018, optimizing cloud costs is the top initiative across all cloud users. So this is a good place to start. This told me that this was something that was very relevant for people using the cloud, deploying on the cloud, and I thought there might be a way to make this more available for people using Tableau as well. Now let's dig into a little bit more of the why behind this. Why is this relevant? Why is this important to our customers? So first of all, managing costs is a top priority for organizations at every stage of cloud maturity. Now this is an important point here because we see that customers are all across the board here, especially with people using Tableau. We have customers who are fully deployed on the cloud. They've been there for years, and they're actually leading the way in terms of what you can do on the cloud and what those deployments look like. But we also have a lot of customers who are new to the cloud and a lot of customers who are taking sort of a multi-cloud or a hybrid cloud deployment. So we see people across the board. That means that their needs vary quite considerably. So we're seeing lots of different requirements for how people need to manage their cloud infrastructures. However, a consistent theme there is that enterprise IT is playing a strong cloud governance role. Now that means that IT is bearing the brunt of the work that's required to maintain these cloud deployments. So managing them, increasing transparency into what usage looks like, forecasting costs, all of that is falling under the umbrella of IT for the most part. And one of the most shocking things to see here is that only a minority of companies actually have a strategy for automating cloud reporting, managing all of their costs and such, so on and so forth. So this is something I thought, all right, we need to fix this. We need to find out how we can better support our organizations as they scale so they can manage these costs as they continue to increase and adapt and improve their cloud deployments. So I embarked on my own little journey here, just 1 p.m. on our own, trying to figure out a way to solve this problem. So you're going to see my story, and then we're going to see how customers actually tackle this story. So we're going to talk about a sort of small little POC and then blow that out to a larger perspective. So this is what I did. This is the process and the workflow that I created to bring cost and usage information into Tableau. So the first thing we see here is you can actually set up cost and usage reporting in AWS. So that was a great place to start. They give you that right off the bat. It's a pretty easy 1 or 2 click to set that up. Now that's going to dump a very, very detailed report into S3, and as we saw Ryan talk about, this is a common theme that we're seeing across lots of users and just lots of processes and services in AWS in general. Using S3 as that sort of staging area, almost a data lake, where you can collect all of your information. Now it comes into that S3 bucket that you designate in a compressed zipped file, and you get a little bit of data shifting over time, so the structure can sometimes change if they add or remove columns, and you often sometimes get a little bit of duplication just because the fact of the matter is you're getting a lot of data shoved in there. So the next thing I needed was a way to clean that up, and this is an important point because I wanted to clean it up so that I could open it in Tableau. And for those of you that have used Tableau, I'm sure you've had that experience of, okay, what does my data need to look like so that I can open it and get to exploring it right away? I don't want to have to worry about the structure. I don't want to have to worry about splitting and merging my fields and doing pivots. I want it to be really nice and friendly when I open it up in Tableau. So enter Lambda functions, which are a really fantastic way to get in there and do exactly what you need to the data that you have in S3 or lots of different places in AWS. So I set up an event trigger, wrote a little Python script in Lambda, so serverless, which meant that was all handled for me by AWS services. All I had to do was write my script. It would run on command. What this did, it cleaned up the CSVs, unpacked them, structured them a little bit more nicely, and dumped them into another S3 bucket. Now, this is a really cool aspect here, the ability to use Lambda, which means you get to determine how it's formatted and the structure you save it in. So eventually, I'd like to expand this, and I think maybe Parquet potentially, but figure out ways to improve the performance of these files that we're storing. But that's a cool aspect because it kind of puts it in your hands to determine how that's going to work best for you. Now, at this point, I decided to use Athena. Like I said, just one girl on a mission, so I wanted to keep it simple, get in, get out, make it fast. So I wrote a real quick Athena query here to just establish that semantic layer. However, at this point, I also wrote a couple different options, so you could also output it to Redshift. And this is where I want to emphasize again that you can design the solution to fit what your organization needs. So we're going to see later on in the presentation, UMD took a slightly different approach based off of how they needed to structure their data and where they needed to store it. And then I got to a place where I felt the most comfortable. I got to open up Tableau Desktop, use our direct connector to Amazon Athena, and open up that data source. Now, like I mentioned, it's a hefty data source. There's quite a bit of information in there. You get plenty of dimensions and measures to play around with. So I spent quite a bit of time drilling into what was important, doing a lot of exploration, and ended up building out this little prototype here. So this is a dashboard that really is just a high-level overview of our cost and usage in actually our consulting team's little sandbox. So this is what we give to our field reps if they want to demo AWS or just explore and do some learning. It is currently a functional production dashboard that we're using. And so already with this one, you can see you get some interesting peaks and valleys, and you can pinpoint where you had some levels of high usage and high cost. You might notice there's something around mid-May there. Looks like a consultant got a little overeager with her server testing. That was me. Um, and at this point, I kind of wanted to take my journey to a different level. I thought, all right, this is useful for me already. This has to be useful for other people. So I actually went and talked to our Tableau Online team, and for those of you that are familiar, Tableau Online is actually a server that we host on AWS and we provide to our customers as a SaaS solution. I went up to the Tableau Online team and I said, hey, you guys should definitely check this out. Like, I don't know if you're doing reporting. And they said, yes, well, Madeleine, this is a multi-million-dollar process that we have running here. Of course we have reporting. Turns out they're actually using a very similar process, which is really exciting. Of course, their dashboards address slightly different questions. It's not more sandbox-focused. It's more department-focused and region-focused. So this brings me to this point here, which is, as I kind of mentioned before, the uses and the needs of all of our customers are going to be different. There are lots of different metrics that people will look at when it comes to monitoring their AWS deployments. So maybe it's cost and usage spikes. Maybe it's tracking down rogue instances, determining when to switch over to reserved instances. I've spoken to some customers who are doing end-of-life analysis, so to figure out when you need to upgrade your operating systems. Lots of different sort of approaches and perspectives you can take with the data available to you. So in this example here, I built out one that just focuses in on our EC2 instances, identifying spend, which regions we're looking at, where we see the most usage and cost coming from. And also operating system. So we recently released Tableau Server on Linux, which is great because you can save quite a bit of money if you're running on the Linux platform. So I decided to use this dashboard to actually identify where those cost differences were coming from. How much could you actually save? And how could you maybe predict where those savings would affect you the most? So what's next? We've got cost and usage, and I put a little check mark there, but you'll notice it's yellow, so I'm not quite done yet. The idea here is to start creating a repeatable solution. So my journey to create this little POC is pretty much over, and now I want to make it into something that more people can use. So the idea is to create something along the lines of one-click deploy that sets up this workflow for you and also gives you some dashboard starters in Tableau that you can use right off the bat. So we'll see where that goes. That's the plan. And then also to broaden this out to security as well. So I think that this is a pretty repeatable workflow, and I'd like to bring in additional options and other pieces of data that you can put together to essentially create a management portal where you can use Tableau dashboards to really increase the transparency and visibility into all aspects of your AWS deployment. And so with that, I'm very excited to introduce Michelle and the UMD team so you can see what this looks like in practice.
Thanks, Madeleine. I'm Michelle Appel, and I'm the Director for Assessment and Decision Support at the University of Maryland. Presenting with me today are my colleagues Tom Dobrosielski, who's also in Institutional Research Planning and Assessment, and Eric Sturdivant, who's one of our solutions architects in IT. And so this is a partnership that we've had. Let's see if I can figure out the right mouse button. Okay, it's the bottom one. So I want to just give you a little bit of a project overview and why we went down this path to set the stage, and then Tom and Eric are going to show you actual reports that we've got actually in production. So I first think it's important to understand why we needed to do this, because we spent a fair bit of money to implement Tableau and implement this ecosystem. And we had an old Cold Fusion electronic fact book. That's a thing that universities have to tell you how many students, how many employees, those kinds of things. It was out of support, it was no longer performant, and it was a high risk for the university in terms of security. We also had some canned kind of on-demand reports that were sitting on a Hyperion server. Hyperion is now Oracle Studio. That server was incompatible with most modern browsers. In fact, you have to have an old version of Internet Explorer to access those reports at the moment. So it was also out of support, and again, a high risk. Our ad hoc reporting, so that's sort of you make your own reports. Most of our users are using a desktop Hyperion, again, Oracle Studio product, which we have support for some value of support. And so we classified that as medium risk. And then our warehouse, I'm not going to tell you what version of Oracle it's on, but it's on non-performant and outdated model. And so, again, medium risk. It's still secure, but I like to say that before we started this project, we were state of the art for 1999. And so we needed to move ahead and change that ecosystem. And so our goals were to reduce that risk. That was the first kind of piece. Reduce the risk by implementing some modern analytics. We also needed to modernize our data architecture, make it more more performant, but also support a very decentralized environment that we have at the university so that people can write reports knowing what they've got. We wanted to, improve the quality of our data and our metadata. Again, people were writing reports on fields that they had no idea what the field was. And we wanted to automate as much as we could and to set up an ecosystem that would allow people to just come to our ecosystem and with very little training and very little initial effort, plug in and go. And Eric's going to talk about that. So I apologize if this is too small for the back row, but we have these 4 work streams in the project, and they're all kind of moving together to get us to this ultimate goal of a modernized ecosystem. Executive reporting is where we've got our Tableau activity going on, and so that is for people who don't need to learn to program, to code. We build the reports, you come. The next slice is that data extraction and ad hoc reporting, and we decided on a different solution a year and a half ago because Tableau didn't have prep. And as Madeleine talked, you really need your data clean before you come into Tableau. And so we're looking at SAS, at SQL, at other solutions that help us prep our data to get it ready. Data modernization is our AWS data warehouse transformation, moving things into Redshift. And then I think this is the most important piece, is that we're documenting our data as we do all of this. So as we write reports, we're documenting what does that report do, what questions does it answer, what questions does it not answer, so that folks get the right answers to the questions that they have. And I think this is something that we sometimes miss when we're doing a big implementation. We think about getting the data where it needs to be, or we think about getting the reports written, but we don't think about the data documentation. So this is our very, very simplified, not for a technical audience, but you're techies, so our infrastructure. We have an AWS S3 bucket that we're running HTML, CSS scripts that powers this reporting site called reports.umd.edu. And we chose that because it's cheap. It's an affordable way to host the straight HTML content, and because we needed a public face to the rest of this infrastructure, and a public face that my office could reasonably manage. We are technical adjacent in my office. So we, because of some security issues, needed the reports that the public was going to see to not be in our Tableau server environment. We had VPNs set up, we have logins enabled, and we did not choose to implement the guest access on Tableau server. Instead, we're using free Tableau public and putting aggregated data extracts out on Tableau public for things that any of you could see without a login. Then on the other side, we have an AWS EC2 server set up. And that is running Tableau server on a Windows box. And we started small. We have not maxed out on that yet. And when we do, the EC2 will allow us to just get bigger as we need to. And then sitting underneath that, we're connecting to a variety of data systems. So we're connecting to some data that are already in Redshift, that have already been modernized, some data that are in Oracle, and some data that are just straight extracts. And those decisions get made based on access and on performance. So when we started down this path a year ago, we had 6 analysts that were writing reports. We had 10 reports up on the public website, and we had maybe 25 users. A few hundred hits. We're monitoring that with Google Analytics. In the summer of 2017, we added on some users, and by the fall, we got off of our old Cold Fusion application. And when we did that, we also set up a structure that allowed for a community of practice to come into that ecosystem with a common look and feel. Now we have easily over 25 people that I'll call analysts who are writing reports, not all of them in my office, spread out across campus. Easily over 50 reports sitting on our server, hundreds of users, thousands of hits. Tableau makes it super easy to go in and see how many new people you've got per week, how many hits you've got, what they're looking at. And we have the ability then to make that ecosystem bigger. By next year, we hope it's even bigger. We keep running out of Tableau licenses on campus, which we see as a good thing. So we have a bulk buy license, and we re-up every 10 licenses, and we keep running out because we've got more and more people now choosing to do their reporting in Tableau. So we expect next year even more growth. With that, I'm going to let Tom talk about what it looks like on the public and the campus side, and then Eric will talk about billing.
All right, thank you, Michelle. I'm Tom Dobrosielski. I work at the University of Maryland. I'm an information and design specialist in the Office of Institutional Research Planning and Assessment. So what we're going to look at for our demo are a couple of slides that we have. Instead of screenshots, we've opted to use animated GIFs that will show you a little bit of the function of our site and show what we've built for the campus community. You might not be able to read everything, but it'll give you just like a taste of what we have going on. All right, I did the right button. So we have this, as Michelle mentioned, on an Amazon S3 bucket. We have an HTML site, and it's our primary access point for all of our campus reports, both public-facing and for campus employees. Here you land and you identify yourself as either public or a campus user. The public sees this, where we have our 10 public reports, and we have them broken out into different categories that you can see. And when you click on a report, it will open up, it will give you some navigation as to the Tableau environment, like the tools and how to navigate. You can say you don't want to see that anymore, and then you have your report. I won't go into too much detail about the actual report itself, but the layout, we have a title and a footer, and this, we use a campus template so that all of our reports will look the same across public and campus and across different offices. In the top right corner, we had a report description. So as Michelle mentioned, data documentation is very important to us. And so that has some information about how to utilize the report, what data you can find in it, and what you cannot. So those are our campus reports. If you were a campus user, you would select campus at the beginning, and you would have a statement of understanding saying that you will use data appropriately, and then connect using a a campus login that has an MFA. If you are off-site, off the campus wireless or wired connection, you would also need a VPN. And that will take you to what we built as a report navigator that has a list of all of our campus reports available to everyone. You see a report description. You can search by tags that have been attached to the reports. And we have them also separated by the content areas, which are the projects in Tableau. You have access to your favorites at the bottom, and then as well as a few little categories of your top 5 viewed, the campus top 5 viewed, and the most recently updated reports. And so this is something that we built using a Tableau workbook connected to the Postgres data. So as soon as we add a report to one of our campus projects, it's immediately in our navigator and available for anyone to access. Clicking on a report, you can see that it has the same look and feel as our public ones. There's some additional functionality in our campus reports and some more nuanced data. We have 10 public reports and about 50 reports that are available to all of our campus employees. And another thing that is common across all of our campus reports is a report description tab, which has our data docs tool. Data docs is our homegrown tool for data documentation, and it has all the stuff that Michelle was talking about. How to use the report, what elements are in the report. You can click on that element, and it will jump you to a nuanced definition on that element, so anyone has access to know exactly what they're looking at. So we, in developing this, we wanted a clean, consistent, common look across all of our reports, and that's what we accomplished with our template and what we were able to do with that site. We have a link on the report to go to the Tableau server in case you want to see reports that aren't available for all of campus. We have some that are for specific audiences that remain on Tableau server and not in our navigator, as well as if you are an author of a report and you are working on something in one of your own sandboxes, you can access it through there. All right, and now Eric will come and talk about the AWS billing data.
Thanks, Tom. I am Eric Sturdivant. I'm a system engineer at the University of Maryland with Division of IT. And what I'm going to talk to you about today is how we use Tableau and the decision support environment that Michelle talked about to analyze our AWS cost and usage data. Like a lot of public institutions, we have to do a lot of procurements through resellers, and that includes how we buy AWS. And one of the downsides to procuring AWS through a reseller is you don't have access to the payer account. So I can't use the AWS native tools for doing spend analysis. I don't have access to budgets. I don't have access to Cost Explorer. They recently announced support for reserved instance coverage information. I don't have access to any of that. It's all in the master account, and my reseller owns that. We don't own that. So the solution we came up with was to get our reseller to provide us with copies of the cost and usage data report, so the CSV files that Madeleine mentioned earlier. And using a very similar process to what she described, we load them into that ecosystem that Michelle talked about. So we plop them into S3, we load them into Redshift, and we point Tableau at it. What you're seeing on screen here is Tableau configured to talk to a Redshift data source, and the columns you see are all those that are available in that cost and usage report. So product codes, blended cost, unblended cost, regions, all the kind of dimensions that are available in that data. And so one of the first reports we developed, and probably one of the most important ones, is the ability to do analysis of our reserved instance coverage. We have over 70 active AWS accounts, and without having access to the master account, there's no native tools for analyzing your reserved instance coverage across all of those accounts at once. So this report shows two things. At the bottom, you'll see instance counts by hour and by instance type. So in blue, it's T2 micro, T2 small, T2 medium, that kind of thing. And the spikes you're seeing there are most of our applications, most of our users of our applications are on the East Coast. Most of them work business hours. And so you're seeing scale-out spikes, Monday to Friday, 8 to 6, as users are using the applications and as developers are spinning up development and QA environments for doing work and testing. What you see at the top is normalized usage of those reserved instances. So AWS has a reserved instance feature called instance type flexibility. This on Linux instances means that you can buy a T2 micro reserved instance and apply it to half of a T2 small. Or you buy a T2 small reserved instance and apply it to 2 T2 micros. You don't have to worry about as much the different sizes of instances that you're using. You can just buy T2 reserved capacity and have it apply across the board. They take care of all that for you automatically. And so the top part of that graph is showing you those normalized units. And what we do as a team is sit down once a month and kind of analyze how much we're using, how much of that is reserved, how much of that is on demand, what do we think we're going to be doing next month, the month after that. We can see a kind of a slow, steady trend up on this graph. And we buy RIs once a month to kind of keep between 80 and 90% of our on-demand coverage. This next report makes use of a tagging structure we apply to all of our resources in AWS and has a number of dimensions that let us drill down into individual applications that we run. We have a Java platform as a service we provide to our developers to run most of our enterprise applications. And this lets us get cost for each individual application, the environments that applications run, so dev versus QA versus production, and then actually has a drill down on the right-hand side to allow you to see the underlying AWS services and components that make up that cost. So one of the top ones on there is Testudo. That's our student information system. I can drill down into the production cost versus the development, and I can see how much we're spending on EC2 compute versus storage versus data transfer, how much we're spending on CloudWatch metrics, how much we're spending on load balancers, all that kind of stuff. One of the things that came out of being able to do this analysis was the realization that we were spending quite a bit of money on load balancers, and they were mostly idle load balancers. As I mentioned earlier, our non-production environments are off most of the time unless the developer's using them. There's no off button on a load balancer. I can stop an EC2 instance, I can turn an auto-scaling group down to 0. You're paying for a load balancer whether you're sending traffic through it or not, as long as it exists. And so that led us to, with a couple of AWS features, a model we called shared ELB, where AWS in their application load balancer product came out with a couple of features where you can have that load balancer route traffic to different target groups based on HTTP host headers. And they raised the limit on the number of routing rules from 10 to 100. What that let us do was take a single load balancer and configure it to route traffic to multiple independent applications underneath based on whatever the URL the user typed in. So rather than one load balancer per application, I can have one per essentially 100 applications. So this is a report that we didn't publish, we didn't make available to campus. It's still using the same template that Tom created, so at least it looks reasonable from a look and feel point of view, but made available to the team that was rolling out that shared load balancer model so they can track the progress. What you'll see is we went from, in our Drupal environment, spending about $3,000 a month on load balancers to, when this is all said and done, we're spending about $400 on load balancers. This graph flips back and forth between cost and load balancer count. And on the load balancer count side, which is popping up in a second, you'll see some pretty significant spikes down, and that's where our operations team made some pretty heroic efforts to roll that feature out in chunks through development and then QA and finally into production over a holiday weekend. And this last report kind of, I want to demonstrate sort of the ability of digging into very large data sets with Tableau. I'm not a data person. Michelle, I'm on a panel of people who know how to say the data are rather than the data is, and I'm not that person. This data is large for me. We're 5 or 6 million rows a month, and with Tableau, you can kind of very easily drill down into different dimensions of that data and filter it very quickly. And so I got a request from my management team asking for how much we're spending on the entire BI environment that Michelle is running. What are the underlying components? How much do they cost so that we can actually, some of that's going to be funded centrally by campus. And so I was able to use Tableau to slap this report together, pull out the total numbers, paste them in an email, send them off. And then, of course, 4 weeks later, I got another email saying, can you do the same thing, but can you get live data from that? And so at that point, I can take the same ecosystem that Tom and Michelle made, I can slap the same template around this report, I can publish it to Tableau server and make it available to the 4 people in leadership who want to see this data, and they can mash refresh as often as they want. We load this data twice a day as AWS makes it available, and so you get near real-time availability of what we're spending on this stuff as it happens. So a couple summaries, key takeaways, I guess from all of this is AWS really makes it easy to scale Tableau and business intelligence in general. You can start very small. You could buy a Tableau server from the marketplace on a small EC2 instance, license it for 10 users and run it in a small team. play with it, start to explore it, and as you grow, both from your data needs, the things you're putting in it, as well as the teams that are using it, you can scale that out. You can get bigger instances, you can get more Tableau licenses, and off you go. You can also try to extract value out of this in a number of different ways. There's a bunch of slides that were up earlier showing you lots and lots of service icons that you can pick and choose from. So how you store your data, how you analyze your data, the different tools that you pick. There's lots of choice there based on technical requirements, budgetary requirements, the skill set of your team. There's a bunch of different ways you can make the same kind of thing work in this world. And the last one is really being able to do analysis of your AWS spend. Kind of as Madeleine was talking about earlier, it's almost impossible for us to be as far along as we are in our cloud migration without being able to analyze the spending that we're doing, be able to make design decisions to optimize that spend, and really have an idea of where our money's going across AWS environments that we manage and those that we don't. So, I think we have a little bit of time left. I guess we're going to open it up for questions. There are microphones in the middle. Crickets. Okay.
Can you hear me?
Yeah.
Are all of your data sources hosted on AWS, or are they hosted in different data centers?
They're in different data centers. So Michelle's slide had Redshift and Oracle. Some of those Oracle are on-prem, and so that's Tableau and AWS connecting to Oracle on-prem over Direct Connect.
We also have folks who are pulling their survey data that is, either in Qualtrics or in some, little on their desktop Excel file, and then they upload that Excel file to Tableau server, and they can control it so that nobody else can see the raw data, but then their survey data are up there. So Tableau has so many data connectors and so many ways to manage it that, I would say you could do this with none of them on AWS or all of them on AWS.
And just a quick follow-up, those connections between AWS and those data sources, could you kind of briefly go over that process, like monitoring the latency and establishing those connections?
I can tell you from our personal experience, and then maybe Ryan wants to talk about it. So one of the challenges sort of out in the field is making sure that your report writers have the appropriate connectors on their actual machines, because you're going to write a report in Tableau on Tableau desktop. And so they need to have the right TNS sets and the right Oracle connectors and SQL connectors. Then we have to make sure, so we have somebody recently who was doing a SQL Server connect, and we had to make sure that that connection was also updated on the server. And then things move pretty quickly. So once you've done the first one of that type, then everything is super easy as a report writer. In terms of performance, it depends on how big the database is. So when we see Eric's reports running, they're big, right? The data are big. And so they might take a minute or so to load. Whereas we tend to do ours on extracts because they don't change very often, once or twice a semester. And that is almost instant. It loads very, very quickly. So we try to coach our report writers on, how often are your data going to change? How up to date do you really need this? Do you need it by the minute? Do you need it just daily? We have one set of folks who are extracting, because Tableau you can schedule an extract, so they've got their data on AWS, on Redshift, and then they're running an automated extract every night because their data change during the day, but you don't need that change to be reflected immediately, and so they're running that automated extract, and then their reports perform a lot better. So if they needed to know up to the minute, they could hit Redshift. Theirs is still a pretty small data set, and so it would perform reasonably, but those are kind of business questions that you have to walk folks through to understand the underlying data, how often do they change, and then how does that roll up to what your needs are? Did you want to say?
Specifically on the latency, so our data centers are, I don't know, 10 miles north of here.
Yeah, microphone.
We're, I don't know, 25 miles from US East with direct connect there. We're about 4 milliseconds in and out of Amazon. In practice for this sort of stuff, we have not found that to be an issue at all. The performance slowness I get on the Redshift side is really around the size of the data processing. Michelle's stuff that's fast is coming back to campus. So it's really a distance thing.
Yeah, distance is a huge factor. So the closer you can be, if you're fortunate enough to be near a region, that's a great option. If you're far away, sometimes we hear this with GovCloud. If you happen to be, your data center is in Texas, that latency may be meaningful. Two options for establishing a secure connection. You can either opt for a VPN, so that's going to be an IPsec tunnel into AWS over the public internet. That's going to have higher latency and more fluctuation. Or you can opt for Direct Connect, which is a dedicated connection directly into AWS, sort of single piece of fiber, which will give you lower latency and much more consistent throughput.
Thank you.
Any other question? Any other questions?
You talked about ELB and you are sharing it. Is it like a application load balancer, and what is the mechanism you're using to share it across?
Yeah, so the application load balancer product has the ability to, you can correct me when I say the wrong words, route traffic to different target groups, so different groups of application servers, and you can create rules for how that routing is done. And so what we did is create rules based on the HTTP host header. So if you go to site1.umd.edu, you go to this set of servers running that application. If you go to site 2, you go to a different set of servers running a different application. All using a single load balancer, just with multiple rules and different target groups configured for that.
Any other questions?
Can you go to a microphone? Or talk louder and we'll repeat the question.
It's Tableau support parallel processing.
I don't know
I'm
that
getting a nod
answer.
from the front.
So the question is, does Tableau support parallel processing? So if you have lots of reports getting generated, will it queue those up, or will it execute those in parallel? Is that? So yes, it will. So Tableau server, you can configure it lots of different ways, but part of its scalability is that it will execute parallel queries to populate lots of different reports at the same time.